All right. While they figure out the video, let me quickly start off. As Hema said, I work for Intel. I've been there now for about 22 years. I started as a design engineer in the 486 group and worked across multiple sites. What we're going to do is, we'll skip the video, don't worry about it. Bring the slides back and we'll show the last video. What I'm going to do is give you a view of how Intel sees Internet of Things, and then I'll try to give you some perspective. We won't go too much into the technicalities of the product. If need be, we can spend time in the afternoon. So if I can get the slides up. Thank you. All right, disclaimers. Yeah, I'm sure we won't spend too much time on this. I'm sure the hype around Internet of Things is very high, right? Enough of us read this everywhere. There's enough viewpoints. There's enough possibilities which people bring up. What we have sort of summarized is there's going to be billions of devices, billions of sensors, lots of data, a lot of it probably unconnected initially. And we'll start thinking about that, what to do. Now, while we put this up, a lot of people ask the question, why do you believe this will happen? What drives this, right? And we'll touch upon that a little bit. A few things to think about is sensors, right? Practically everybody in this room is carrying a phone which probably has 20 to 30 different sensors, right? A lot of them are actually manufactured and produced in Japan, designed, manufactured, produced in Japan. But the important thing is, I'll just take one example of one simple sensor and show you the power of the sensor industry, right? All of us have a camera in our cell phone. That camera moved from something which you held like this to something which you held like this, and you were able to share information once you click that picture. That sensor, if I could call camera as a sensor, created a multiple billion-dollar industry in hardware and a multiple billion-dollar industry in software with the likes of Instagram, Pinterest, Facebook. I'm sure at least many of our Asian friends, we wake up in the morning, look at our Line or WhatsApp or whatever, and it's flooded with stuff which you like and maybe you'd rather ignore, right? That's the power of what these sensors are doing and exploding, the industry. Bandwidth, right? Cost has come down. I won't spend too much time on the bandwidth. It's a significant reduction across the globe. Cost of processing, largely driven by manufacturing techniques and people like Intel, cost of processing has come down, right? So while I talk a lot about the big numbers, we also want to start thinking about what is likely to drive and get us to those numbers. And then we'll talk a lot about the issues, which will be needed to cover once we get there. There's many viewpoints. This is one more viewpoint about how we believe Internet of Things from a numbers perspective is going to play out over the next 5 to 7 years. You can see the standard verticals which play up. No surprise. If you look at a very Asia view of this is sort of broadly the breakup. Manufacturing, again, no surprise, becomes manufacturing, industry, energy, is in that if you club that together, becomes a very important piece of a share of that pie. Let's sort of dive into it from a sort of Intel perspective. I'll quickly touch upon it and then get to what the industry is viewing, right? Our history is, obviously we started with PCs, servers. Fundamentally, we're a semiconductor company. We do about $55 billion of revenue a year, largely semiconductor and platform, right? Very little, on other things in software. And we've fundamentally believed in building standard building blocks, open source, industry standards, give it to the industry, and then the industry innovates on top of that, right? And we'll talk about that a little bit. Now, I don't expect you guys to read this slide, and we'll probably talk about this a little bit in the later session, but there are many tenets in terms of IoT. And what I'm going to do is just walk through 5 or 6 words. Please don't try to read the sentences, and I'll just talk about the highlighted words, right? Services is an integral portion of IoT, right? Which is where this room plays in, and many of the customers and partners like Quest play in. And we'll talk about that a little bit. Analytics is really important. You're going to get a lot of data. What you do with it is, so data is very interesting. It costs you to collect data. If you don't use it, it's more expensive to store data. And data is like fish, right? It's good when it's fresh. It gets really bad, right, as soon as it ages. And it's really important for us to think about that while we're collecting data, what you do with it is critical. Provisioning, right? Very complex term in the industry, manageability, provisioning, et cetera, but in very simple terms, deploying IoT, of course, has its challenges. Managing it, provisioning it, updating it is very, very important as your systems get complex. More importantly, as you start relying on that system for mission critical stuff, becomes even more necessary. Interoperability, right? You're going to have hardware components from many vendors. You're likely to have software components from many, many vendors, from open source industry, other productization. The ability to put all of this together is going to be leadership. B, making sure this works interoperably and connecting to other systems is going to be really critical, right? We can, in the earlier days, we used to call it islands of computing or islands of data which don't talk to each other. And we like to make fun of our government, so it's like the Indian government, right? The revenue department does not talk to the guy who registers the land. So while I pay taxes for this piece of land, it could be owned by Raman, right? And I'll be paying tax for his land because those two departments talk to each other. And I'm going to pick on Raman, Ajay, where I don't know where you are. I picked on him last night. I'm going to keep picking on him today, so we'll keep the trend. But getting these together, getting the systems to talk to each other is really critical. Can't overemphasize that. As many of the governments across the globe are looking at smart infrastructure, smart cities, smart factories and stuff. The one learning for me at least, and many of our teams over the last, I would say, year, 6 to 8 months to a year, was we had not realized the importance of security in this whole journey. Right? Now, security in our mind was, yeah, we're going to throw a bunch of firewalls on the servers and we're good. But as we have talked to customers across the globe, security, interestingly, at every layer comes up as very, very important for customers. Right? And we'll talk a little bit about that. So there's a lot of detail we'll present, but I kind of wanted to give a view that we believe that if you want to get to leadership, these are a few things which we sort of need to work towards. Standards. I'm really apologize for the people who are in the back of the room. You may not be able to read all of this. Doesn't matter. We'll get the material to you. And by the way, I have most of this translated in Japanese also. I'll try and get this to you before the end of the day. The standards in the industry, there's two big ones, Open Internet Consortium, Industrial Internet Consortium. They have sort of charters which are looking at slightly different things but do a very critical role. We won't spend too much time on this, but I would encourage you to look at what these guys produce, to look at some of the recommendations from them and start putting that in your practices, maybe even in your procurement, maybe even in your capability. Because as we work with multiple vendors, the interoperability, which I mentioned previously, is going to be helped by many of these standards bodies. Right? Open Internet Consortium focuses a lot on industry solutions and open software solutions. The IISc focuses more on the reference architectures. right, in terms of what people need to build, and a lot of the frameworks and the test beds which give you interoperability. If nothing else from this presentation, I want you to walk away is, I'm sure enough people will tell you how great IoT is. I'm going to tell you a lot about what you need to worry and prepare for as we embark on the IoT journey. And then we'll talk about products also, but again, this is important. Maybe we'll touch upon this more in the afternoon. I touched upon security a lot, right? Then are the aspects of privacy, and compliance, right? For somebody like me who travels across airports overseas and India, I probably touch 4 to 5 airports outside India in a month. Now, if every airport in all these countries was grabbing my pictures, my video feeds, what are the new laws of what they can do with it, right? I check into probably 10 hotels or 5 to 10 hotels in a month. I'm all over the place in a good and a bad way, right? What happens to those? Factory workers, right? Your workers are walking in, walking out, you're grabbing pictures. What happens to that? Unclear right now, right? So you might want to start thinking about that before that becomes a sort of liability from your customer perspective. Compliance. A lot of the compliance requirements around this are very undefined, especially in emerging markets, right? Very undefined, very unclear. You could interpret it your way and probably get it wrong, So something to sort of think about as we collect a lot of data. And I just give you one example of the pictures. Fragmentation of vertical markets, we touched upon this. 2 different departments not talking to each other. Within your factory, within your building, does the energy system talk to the security system? Does it talk to the fire safety system? Are they interoperable? Can you manage them together? Legacy. A lot of discussion comes up is IoT for new infrastructure, or can it be done in existing infrastructure, right? And we can spend the rest of the day debating it, and I'm sure there'll be many viewpoints about don't even try it for old infrastructure, do it only for new. Or, well, excuse me, we can relatively easily do it for existing infrastructure. But something to carefully think, and now the software tools are very easy compared to past to connect it back to legacy. Connectivity. For most mature parts of the world, connectivity is not a very critical conversation. But for the 4 to 5 billion odd people which live in sort of this part of the world, Asia, Southeast Asia, Indonesia, etc., China, it's a little bit of a problem. Our connectivity is not that great, right? And actually, even in mature parts of the world, if you've got people on an oil rig out there with mission-critical stuff on it, I'm sure you'd have to build systems with potential breaks in connectivity, right? You want to start thinking as you sort of design that. Many years ago, I ran an effort called occasionally connected computing that sort of seems to be coming back in this deployment. I talked enough about underutilized data and interoperability and standards. I won't touch upon that, but keeping these in mind, Intel took an approach, and I'll move slightly faster from here. Intel took an approach to, I think I moved 2 steps forward. Sorry. Yeah. We launched something called IoT Platform. It's a software framework and a reference architecture. In fact, we just did a press announcement 2 nights ago on November 3rd and launched a new version of it. I'll give you a little bit glimpse of that, but essentially the idea is to help the industry across the aspects which we talked about: security, manageability, connectivity, performance, all the stuff, the challenges which we talked about, and sort of how to address that. Most of it is available online. And the thought process was, I don't expect you to read any of this. The thought process was, you've got the factory floor, or you've got the environment where you collect the sensors, you've got the data center or the cloud where a lot of this comes together, and then you've got your third party or consumers connecting to that infrastructure. Keeping that framework in mind, what are the pieces, where would you put together? Now, if I drill down further again, just look at two colors here. You don't need to worry about the words at all, right? There are two colors here, brownish and blue, right? The blue is the data, and the brownish below is the control of that data, right, at various levels. And then the sort of purple in the back is what you do with it, or the analytics behind it, right? So we've looked at this at various stages, and then when you look here, all of these are the various sensors which could be in your home, your building, your factory. You start to put together the complexity of this and say, okay, I'm going to put all of this together and see how this plays out, right? And then you start looking at all the tenets I talked about at various layers. And you start saying, okay, well, I need stronger architectures, references to sort of pull this. I won't go into the product details. Then we said, how is all this going to come together? Right? End of the day, it's developers who are going to pull this infrastructure together, look at the solutions, and say, what do we do with these? So we started thinking about developers and said, okay, I mean, that's my sort of day job, which is I help developers to be productive. My job is to give enough tools to developers in your organizations so that they can be productive, they can put these solutions together, and they get the right level of technical support when they're putting these together. And then developers look at various stages. They look at the early stage evaluation, start building things together, and then deploy. So let's drill down a little bit more. What we did was we said, from our hardware perspective, and this is now an Intel product-oriented view, which is we've got to support bulk of the environments. Right? And you can see all the logos on the bottom. Just make sure we work with all these environments and some of the newer environments like Brillo, Zephyr, and those kinds of things, so that we're not, for the extremely low-end, low-power segments, we want to make sure that those are covered. As you move above in the stack, you've got to make sure all the elements of cloud are integrated into this developer environment. So essentially, people are going to write for the cloud, right? Or they're going to use the cloud to put your pieces of data. And then as you move higher, and each portion, each section of this has a drill down on our websites and stuff, but the thought process is a developer will need to worry about a few layers of software. This is not about writing an app for your phone where you pick a iOS or Android, get the developer kit, get 10 engineers over the weekend, and 2 weekends later you have an app ready, right? Not going to be that trivial, especially when you're trying to put together a slightly more complex system. And then we have a specific IoT commercial developer kit. In fact, if my memory serves me correctly, the first rollout of that commercial developer kit will happen in Japan. My team is doing it in Tokyo, I think, in the first week of December. We're going to be training developers there, and then we're going to roll it out in this part of the world. Actually, we're going to be doing US in Q1. We're going to start with Japan in Q4. We believed that this is very important to make sure developers understand all these various levels, give them all the tools packaged nicely so they can get started and at least experiment with what needs to be done. And also the way we've looked at this is, okay, fine, we've got a bunch of products. Again, I know you can't read this in the back, but we looked at the various sectors, right? For example, at the very low end, we've got sensors, device controllers, display controllers in the retail environment. We've got beacons, industrial sensors. It's a very different section where the power requirements, connectivity requirements, protocols are very different. How do you give them enough solutions with small footprint over there? And then you sort of move towards the high-end, back-end, cloud, et cetera, et cetera. Right? The thought process, again, is the expectations of deployment are going to be from sub-milliwatts or really sub-milliwatts to tens of watts in your back-end of data center, and you need solutions at each layer. Now, one of the other, let me see if I've got that here. actually, one of the other things I'll touch upon the edge gateway, right? I mean, this was something which has become very interesting. A lot of our customers keep coming back and saying, we'd love to get into more of that. And the example I gave to somebody last night was, let's assume that this hotel infrastructure had about 1,000 sensors, right? Temperature sensors, fire sensors. Actually, let's stick to temperature sensors, right? Something in your room, something in this hall, etc. Every few minutes or whatever the interval is, that sensor is collecting a piece of data, which is it 24 degrees centigrade or 23 degrees centigrade? And then, makes a decision whether, I should do something. And typically there's a controller in the traditional days which informs the controller it's 24 degrees centigrade. You make a decision on what needs to be done. As you get these environments connected, right, and especially once you start putting them on internet and IP, there's a very good chance that that sensor is sending a packet of data to the backend saying, oh, it's 24 degrees centigrade. And if you look at 1,000 sensors in this facility sending a piece of data to the server saying it's 24 degrees centigrade, that server or that backend is going to be pretty overwhelmed. More importantly, does it need to know every 5 minutes or every 3 minutes that it's 24 degrees centigrade? Probably not, right? So you start moving that decision-making and compute closer to the infrastructure. You put a little gateway, like we had the old controllers where you would set the temperature, you put a little compute gateway in something hidden in the back of the wall, which collects the data from all the 1,000 sensors and a whole bunch of other stuff and says, okay, it's 24 degrees centigrade, we got it, keep at it. And then all it does is maybe every hour, 2 hours or whatever, sends a message to its corporate headquarters and saying, we're good, don't worry about it. Now the next stage comes is you can start programming rules which says, how do you optimize power, right? All that can be done in that little edge gateway. I'm giving you a very simple, trivial example of temperature sensors. But the principle is, if you can move that simple analytics closer to the sensor, or what we would call it closer to the edge, so that your backend does not need to be burdened with all of that simple data coming. One. Second, connectivity. Right? If you are not connected for whatever reason between this facility and their corporate headquarters, we're not going to freeze or sweat over here. Things will be fine. That little controller will take care of itself. It's not too dependent on mothership every 3 minutes and saying, hey, whoa, I didn't hear from mothership. Something is wrong. Right? And it's able to take care of itself. Then the next evolution in that is analytics. As I said, it's a trivial example of temperature, but if you start thinking of factory environments, security environments, the other example we talked about was airports and security. Again, picking on Raman, if we had to really find out where Raman was last week, and we had to scan his face across the 500 cameras in the 4 airports which he may have been, we're looking at 1,000+ streams through which we have to scan for that face, right? There are many approaches. You could bring all of those streams to the backend in the server and run a very high-end compute algorithm and look for it. Or you can start putting computing closer to the camera, if not on the camera, potentially do it in real time. No right or wrong, but you're going to have to start thinking of those approaches of where do you build your compute, where do you put your analytics, and start building an infrastructure which serves your environment. From our perspective, from an Intel perspective, we believe that we're going to give compute solutions more, and it kind of serves our purpose very well also, which is we move more and more compute capability closer to the sensors, closer to the edge, and of course, give very high-end compute capability at the back end to do machine learning, deep learning, retail analytics, customer acquisition type stuff at the back end, which looks at the more strategic stuff and not worry about the transactional stuff. Right? That's a message I'd like to leave, at least in terms of thinking and planning your infrastructure. And before I close, I'll just show one video. I kind of wanted to show one fun thing, right? Which is, oops. If, are we ready with the second video? Okay. So before, hold on, I'll tell you when to play it. The possibility we've looked at is that, for the last, 30, 40 years, I talked about the camera. The camera is a two-dimensional camera which captures an image. But what if computing had eyes? And when I say eyes, I mean eyes as we see it, right? Not just two pairs of cameras, but a little bit more than two pairs of cameras. Let's watch the video and then we'll talk a little bit about it. Please, second video. Many of us have seen drones, no big deal. We've seen drones flying, no big deal. What's important there is that that drone was not being controlled. All the drone had was a destination GPS location of where it needs to get to, and then somebody fired it up and let it go. On the drone, you've got 6 3D cameras mounted, where as it's flying and it's mapping out its location, it's figuring out obstacles. And you saw the environment was a forest. There is no linearity in a forest where you've got a path on which you can fly. It's figuring out speed, it's figuring out collisions, potential obstacles, adapting, changing paths, and in some cases, and you can't just go forward and then sort of retrace back and expect that there's no obstacle. Maybe the second drone is following too closely. And that's why there's cameras all around with depth in it, right? That depth gives computing a whole different perspective in terms of what you could do, right? Many of us have seen vacuum cleaners around the house which sort of go off on their own and clean the floor, right? What if you had more depth on that vacuum cleaner? When it's doing its job on its own, it can actually figure out how far is something rather than going and too close, colliding. Many, many possibilities sort of open up in terms of what computing could do, even in a very industrial environment, right? If you guys are ready, you want to play the first video, if you can? I'll show you another video which I was going to play at the beginning.
We used to tap. Then we clicked. Now we touch. All of our content resting at the surface. But the world is not flat. We're in here, so you can do more out there. Intel's 3D sensing technology, your world in all dimensions.
So I want to end with that and say your possibilities open up in a significant way when computing starts to have vision. So quick summary, we believe the potential is very significant. And while I showed the potential is significant, I also gave you some elements of caveat, things which we need to watch out for as we go down this journey. Why it's become so significant, the theory we have is a lot of the advances in the technology, But there's one more important thing which we believe will drive this, is that the expectations of consumers across the world is changing very rapidly, right? Hema mentioned earlier that I've been working at Intel now for 22 years. The thought process in early days was that we do innovation in computing, and we give it to offices and enterprise environments first. They use it, and then that technology percolated to consumers. The world is now changed, right? The most advanced innovations start with consumers today. And actually, the enterprises are slightly slower in adopting them. So the expectations of consumers is dramatically different across the globe, and something you want to start thinking. The last point is essential, and I can't stress upon this enough. Partnership is key for a couple of reasons. One is we saw all the complexities of different systems coming together. People who need to understand it, people who need to put it together. Partnership is also key in a slightly different way, right? We have very heterogeneous parts of the globe. You go to Japan, Korea, US, most parts of Europe, you have infrastructure which is advanced, which is efficient in many cases, and also well managed and provisioned. Many parts of the emerging world, the infrastructure is still developing, right? A lot more improvements, efficiencies can be done. So partnership could be many of you potentially not just using the talent here, but potentially also selling back here, right, into these markets. Especially, I'm sure, if you've been around here, you've heard of Digital India and the whole push around smart cities, and Indonesia trying to do a whole bunch of infrastructure for their islands. Huge amount of potential both ways, right? Talent and business. That's what I would sort of like to leave you with, and start thinking about.
No, actually, I saw the drone video earlier as well. It was very impressive. I want to ask you, when do we start seeing those drones on Indian roads?
I think the technology is getting there. Now, like I mentioned early on, compliance is going to be an interesting conversation, right? I just came back from Hong Kong on Friday night, and my colleague and I were standing at the airport, and we were looking at a counter of DJI. DJI is a popular drone maker at the Hong Kong airport, and they were selling boxes of drones for about $400, and people were picking it up like they were picking up a box of chocolates. I mean, it was flying off the shelf, literally, pun intended. The question is, would I want my son with a drone near my house, and a few hundred meters away there's an electrical wire above? It's going to get complicated, right? So I think while the technology is coming, the products are coming, how we manage it, regulate it, is going to become super critical before we have interesting accidents. The drones flying around, privacy becomes a huge challenge. What is it looking at? What is it capturing? How is it using? Where is it posting it? Again, as I said, simple answer, technology coming rapidly. Customers' fascination for drones, sky high. What all it can do, bad stuff, governments are worried about it.
Okay. And then as a follow-on,
yeah.
Where do you see first few applications of the drone in our lives?
Yeah, I think hazardous environments is like an almost immediately easy place to go use drones. And when I say hazardous environments, it doesn't have to be super hazardous, but just simple places where, we're constructing a tower, and you want to make sure that all the safety nets have been put. Instead of sending a human up every day evening at 4 p.m. or 5 p.m. to check if everything was done, I'd rather just program a drone with the GPS locations, and it does the circling all the way up and down twice a day. And I could be sitting, and watching it, and I'm fine. Maybe I put in an analytics algorithm, and it checks for the key spots, and I'm good. Right? A friend of mine lives in Oregon, and he has a 30, 40 acre property. What he does is he can't go drive around his property every day. So he's programmed his drone to take a video of the critical portions of his property every day. Right? And it actually detects the light, and if the light conditions are good, the drone just flies around his property, takes a video, and comes back and settles down in the same place on his rooftop. And he sits in the office and looks at the video and is like, yeah, I'm good. No raccoons ate up my animals overnight, they're all fine. So, people are figuring, if you've driven around New Zealand, you can imagine why you would need drones there. That's we're going to have to put a whole bunch of more sensors on Raman than just drones. Sorry.
Narendra, you mentioned about the partnership being a key and about the interoperability as one of the major challenges. And you also mentioned about a couple of partnership initiatives. There are a lot of these partnership the standards initiatives and a lot of consortiums. Intel itself is a member of multiple consortiums. So which of these consortiums or standards initiatives you see as winning and why?
Yeah, so I listed two of them, and both of them, while they're focused on standards and stuff, have, so just like any other industry, any other technology, each company is going to have their own sort of vested interests and going to drive consortiums and standards to their to their benefit. But things evolve. Right? This happens in every industry transition. Things evolve, people are going to get smarter, the industry bodies and technology bodies are going to get smarter, and then we'll reach a point of convergence where most of these standards will get to a point where everybody is going to say, yeah, I'm okay with 80-90% of it, right? Because we all know that if we create too many divergent paths, this industry won't grow, right? And that's why we need to make sure we go back to the standards and stick to them as much as we can. Now, there are many different standards for different reasons. OIC has a slightly different focus. IIC has a slightly different focus. Depending on where you operate, you can pick and follow many of these. Okay? Thank you very much.
Are you born to engineer?